All of you, welcome to this YouTube channel. In this video, we're going to discuss about axis symmetry problem. Here the axis symmetric diagram is given. The Young's modulus of the steel is 2 into 10 power of 5 Newton per mm square. Poisson's ratio is 0.3, and at the center, 2 megapascal load is acting. First, go to preference, select structural, click OK. Next is preprocessor, element type, add element, add solid quad 8 node 183. Click OK. Go to option, select element behavior as axis symmetry and click OK. Then close this window and then minimize this element type. Next step is metal properties, metal model, structural, linear, elastic, isotropic. Enter the Young's modulus of the steel, that is 2e power of 5. Enter the Poisson's ratio of the steel, 0.3. Click OK. Close this and minimize the metal properties. Next step is to creating a model. Modeling, create area rectangle by dimension. Here, consider this one as a first rectangle, second rectangle, and third rectangle. For the first rectangle, in order to create area, x distance 20 mm, y distance 60 mm. Enter x1 distance 0, x2 distance 20, y1 distance 0, y2 distance 60. Click apply. In order to create the center area, for that x1 distance 20, x2 distance 80, y1 distance 20, y2 distance 40. Enter x1 distance 20, x2 distance 80, y1 distance 20, y2 distance 40. Click apply. Next one is to create the third rectangle. The x1 distance 80, x2 distance 100, y1 distance 0, y2 distance 60. Click OK. So now we have successfully created a model in 3 different rectangles for the given dimensions. Since it is different areas, we have to convert it into single area. For that, operate Boolean, add areas, select first area, select second area, select third area, and then click OK. Now the 3 areas will be converted into single area. After completing a modeling, next step is meshing. Meshing, size control, manual size, area, all areas. Enter the element edge length as 5. Click OK. Go to mesh, areas, free mesh, select this area and then mesh. Now the mesh part is completed. In order to check the different elemental plot control, numbering, select element numbering, select color only, click OK to get a elemental plot of the axis symmetry problem. To save this file, go to plot control, select write meta file, select inverted to white or black, save element type as Windows meta file, enter the file name as mesh plot. After completing the mesh, next step is to assign a boundary conditions. Solution, analyze type, new analysis, static analysis, click OK. After selecting the analyze type, next one is define load, apply structural displacement on lines. Select the first line, select this bottom line, then select this top line, and then select bottom line and click OK. So here all the degrees of freedom are arrested. Enter the displacement value as 0 and click OK. So now here all the degrees of freedom will be arrested. Next step is applying the pressure for the structural pressure on line. Select the top line, click OK. In this problem, the pressure value is given in 2 megapascal. So convert it to Newton per mm square, then nothing but 2 megapascal is equal to 2 Newton per mm square. Enter the pressure value as 2 and click OK. So now the pressure is acting in a downward direction. Next was solve current LS. Click OK. So here the solution is done. Close this. Next step is to get the result part. General post process, plot result, deform shape, select deform plus undeform, click OK. Here it is a displacement plot for a given boundary conditions. So here the maximum displacement value for the given boundary condition is 0.002052 mm. To get this file, go to plot control, select write meta file, convert it to white or black. Select save as type as Windows meta file. Enter the file name as displacement plot. Next one is to get a displacement vector and stress plot. For that, go to contour plot, nodal solution, select d-wave solution, select displacement vector, click OK to get the displacement vector plot. Here the maximum displacement value is 0.002052. So the maximum displacement is at the center of the axis symmetry problem, because since the applied load is acting at the center. Select plot control, write meta file, convert it to white or black. Enter the file name as displacement vector. Select save as type as Windows meta file. Next is to get a stress plot. Select nodal solution, select stress, select one way stress and click OK. So here it is a stress plot for the given boundary condition. The maximum stress is acting at this corner. The minimum stress value is 0.077408 Newton per mm square. The maximum stress value is 12.2746 Newton per mm square. To save the stress plot, plot control, select write meta file, select inverted white or black, enter the file name as stress plot. So now we have created two-dimensional model. In order to get a three-dimensional 1. Plot control. Select style. Select symmetric expansion. Then 2D axis symmetric expansion. Then select 3x4 expansion. Click OK. And select isometric view. And then select fit. So here it is a isometric view of a axis symmetry problem for a 3x4 of expansion. Even we can get 1/4 expansion or 1/2 expansion, 3/4 expansion or full expansion. Now it is a 3/4 expansion. To save this file, go to plot control, select write meta file, select invert to white or black, enter the file name as stress plot 3D. Stress plot 3D. So further, to get a result path, list result nodal solution, select stress, select one stress, click OK. So here it is a stress plot for various nodes. The minimum equivalent stress at a node is 104. The value is 0.77408 e power of -1. The equivalent stress at a maximum value is at a node number 58. Value is 12.275 Newton per mm square. To save this file, select File, Save As, enter the file name as list result. Close this window. I hope this video will be very useful. Kindly support this channel, like, share and comment, and subscribe this channel to get further update. Thank you.